When graphing a rational function, one of the quantities that you'll be asked to find is a horizontal asymptote. There are two cases that could generate a horizontal asymptote. One is if the degree of the top polynomial is less than the degree of the bottom polynomial. A quick example of this would be where the degree of the top is degree 1, but the degree of the bottom is degree 2. When the degree of the top is less than the degree of the bottom, the horizontal asymptote will always be the line y is equal to 0. The other possibility is if the degree of the top and the bottom are the same. And here's a quick example of a rational function where the degree of the top and the bottom are the same. We have a degree 1 polynomial in the top, a degree 1 polynomial in the bottom. When this is the case, the horizontal asymptote will be the line y is equal to the leading coefficient of the top polynomial divided by the leading coefficient of the bottom polynomial. So in this brief example, we would have a horizontal asymptote at the line y is equal to some constant. Remember, a horizontal line is going to have an equation, y is equal to a constant, and that constant is going to be the value that is the leading coefficient of the top, so positive 2, divided by the leading coefficient of the bottom, so positive 3. So this would be the equation of the horizontal asymptote. Let's look at 3 quick examples here. We're asked to find the horizontal asymptote for these rational functions. In part A, we see that we have the case where the degree of the top is less than the degree of the bottom. When the degree of the top is less than the degree of the bottom, the horizontal asymptote is always going to be y is equal to 0. No computation necessary. In part B, we see that the degree of the top and the bottom are the same. We have a 6-degree polynomial in the top and a 6-degree polynomial in the bottom. And when that's the case, the horizontal asymptote is going to be the horizontal line y is equal to the constant value that is the leading coefficient of the top, so 5, divided by the leading coefficient of the bottom, which in this case is 2. So the equation of the horizontal line that is the horizontal asymptote in part B is y is equal to 5/2. In part C, we can see that we have again the case that the degree of the top and the bottom are the same. We have a 2nd-degree polynomial in the top and a 2nd-degree polynomial in the bottom. And when the degree of the top and the bottom are the same, we have a horizontal asymptote that is going to be the line y is equal to the leading coefficient of the top divided by the leading coefficient of the bottom. And in this particular case, the leading coefficient of the top is 2, and the leading coefficient of the bottom is positive 1. So the horizontal line in this case is going to be y is equal to positive 2.